We've seen how to solve many differential equations, but there are a few that come up again and again and again. So it is useful just to take a closer look at those ones so that you're able to make use of them immediately whenever they come up. For example, in the section on partial differential equations, we will see some of the equations that we're about to see. We'll see them again, and it's useful to be able to process them immediately. One equation that comes up a lot, the second derivative minus k squared z is equal to 0. So effectively, we have this minus a multiple of z here. When that comes up, the general solution is simply given by ae to the plus kx plus be to the minus kx. And then, depending on whether you prefer to work in exponentials or hyperbolics, you can also write it as c times the hyperbolic cosine of kx plus d times the hyperbolic sine of kx. So that's one that comes up a lot. Another one that comes up a lot is where we simply have a different sign here. The second derivative plus something times z is equal to 0. And if we write it as gamma squared, then we can go straight to z being one constant times the cosine of gamma x plus another constant times the sine of gamma x. And the third case, simply when the second derivative is 0. We can integrate twice and get that z is equal to one constant times x plus another constant. Those are forms that come up regularly, and it's essential to be able to process them quickly. Let's see an example here. We're asked to solve d squared y by dt squared plus 9y is equal to 0. So here's our equation. D squared y by dt squared plus 9y is 0. Let's just make a minor rewrite of it. So we'll write it as d squared y by dt squared. We'll rewrite the 9 as 3 squared times y is equal to 0. It's a plus sign here, so we can write the general solution y is equal to one constant, we'll call it c, times the cos of 3t plus another constant times the sine of 3t. That's the solution here. We've just quoted it on the basis of the equation here. Of course, we can justify it. Let's try to justify through the auxiliary equation. So we'd get m squared plus 0 times m plus 9 is equal to 0, or m squared is minus 9, so m is plus or minus 3i, and indeed let's write this as 0 plus or minus 3i. So then we can say that the solution is e to the 0t, and then we'll have one constant times the cos of 3t plus another constant times the sine of 3t. And of course, e to the 0 is 1, so we're just left with c cos of 3t plus d sine of 3t. So for a simple equation like this, rather than go through the auxiliary equation, when we need to, we should just be able to go directly to the solution.